in this journey, I ended up putting together a lot of what I learned into both the product that we have and also just general principles. This is a whole new paradigm for building software, solving problems, building products and features and so on. And an agent is any system that can understand user intent, make decisions, and take actions. Now we have agents, and for the first time, a lot of the data is actually information that can be used in context. So, hey guys, thanks for stopping by. My name is Diwank. I am an entrepreneur. I've been building AI products for the last 10 years, and I'm building this company called Julep AI, which makes it easy for people to make AI agents, workflows, solve complicated problems using foundation models. And in this journey, I ended up putting together a lot of what I learned into both the product that we have and also just general principles. So this talk is a little bit of a distillation of those ideas. And yes, in general, my background, I've been building since 2013. I was previously chief architect at Electric, which is a publicly listed company, founder of Kia, and also dropped out of Columbia a while back. So I can dive in, but I'm guessing everyone here is already familiar with what agents are. And obviously, this is a whole new paradigm for building software, solving problems, building products, features, and so on. And at its core, an agent is any system that can understand user intent, make decisions, and take actions in some generalizable way, right? And there is a need for new patterns, new ways of thinking about building this kind of software. And the reason you need a new pattern is that agents are fundamentally different from your regular applications. So before agents, we were usually solving problems with deterministic systems. So you had some kind of a database to store state, an interface for actually taking inputs and some logic to run. And it made sense in that system to essentially break those problems down into as small pieces as possible, because that's easier to distribute, easier to scale, easier to manage state for, and so on. But now we have agents, and for the first time, a lot of the data is actually information that can be used in context to control behavior. So for example, if previously you had a shopping cart, you could literally split up every aspect of the shopping cart, its state, and the other parts don't need to know what other parts of the cart are doing. And so you would see even carts, a single shopping cart product having 10, 20 microservices backing it. And part of that was that there was no point in hoarding all of that state in one place. It was just messier. It was harder to keep track of, harder to clear contention. But now you can do something with that state. You can look at the shopping cart. You can see what a person is trying to achieve, what they want to buy, and actually take action. So now it makes sense to have all of that context. But our platforms were not designed for it. So for example, Heroku has a time limit of 30 seconds for any web process to finish. Lambda has a time limit for 15 minutes for any process to finish. A lot of use cases already take longer than that. So my deep research and O1 Pro queries typically take longer than 15 minutes to finish. And these systems were not designed to scale for that. So let's take a step back, rewind back to 2009, 2010. Back then, people were building these applications in a very ad hoc way. Apps were new. SaaS was new. Web 2.0 was new. And there used to be basically two ways of doing it. One was you rent a server, put a LAMP stack on it, and just hack around. Or you could use some systems like Elastic Beanstalk or whatever. And the guys at Heroku actually came up with this wonderful idea. It's called the 12 Factor App Manifesto. It's so ingrained in us now that people don't really usually even know about it anymore. But Heroku founders actually set these principles that applications should be stateless, they should be interruptible, they should be packageable, code should be version controlled, and so on. And that defined how applications would be created and deployed at scale since then. So this is essentially the motivation behind working on principles for building agents from what I've learned. And that's what we're going to talk about today. So these are the 12 factors from Heroku. I won't go into each one of them, but some of these is like, they seem so trivial, but were not best practices at the time this was penned down. So for example, dev prod parity, I guess still not popular in Bangalore, but this was not an idea really outside of a few large companies. Similarly, disposability, being able to package an application, send it somewhere, start and discard it as needed. So all of these add together to make systems extremely scalable. So we have, these ideas to thank for what we could do. So 12 factor apps came out in 2008, I think. Heroku founders came up with it. And they distilled it from their learnings from, their jobs and so on, published this, built a company on top of that. So I'll talk about all of the different factors in a second. So these are the factors, so to speak. But the idea, some core ideas. So each of these is basically just a simple principle. Do this, and this is why I would recommend you do this. This is coming from basically realizing the hard way that prompts are not your regular code, and they're not configuration. They're not pure state. It's a very new idea which needs its own kind of things, tools and so on. Like for example, everyone hates on LangChain. I was one of I was contributing to LangChain very, very early on. And back then, what LangChain was doing was actually amazing. Because back then, people did not know what prompting was. Models were shit at following prompts. So LangChain would collect all of these. Harrison would collect all of these weird ideas, like telling a model, if you don't do this correctly, my mom will die, or some stuff like that. And that used to be part of the code base. Like that, those prompts were in their code. Because back then, these tricks were very important. If you didn't know these tricks, shit didn't work. So what LangChain did back then was actually very helpful. But as models got better, that became actually a problem, because now you want it to be agile enough, and now you can actually do useful things by putting more instructions in it, to customizing it. And then you realize that bundling prompts as a library is a horrible idea. So that's one of the lessons. Again, similarly, being able to run a job or in a process for a very long amount of time is very important. Being able to guarantee its state. And that's a very hard problem as well. So that's what this comes from. I kind of just jump right in. So the 8 factors. First is all prompts should be tracked separately from code. A prompt is not code. Prompt is not configuration either. It deserves its own place, and there are massive benefits. And I'll talk about those in a second. There are massive benefits of tracking them separately. You don't need to follow a specific recipe for it. You don't need to have a certain JSON structure or YAML structure. That is not important, as long as you treat prompts as a first-class citizen of your code base. The second thing is tools. So the principle here is explicitly define and isolate interfaces that models will be using. And this is actually kind of feels very trivial, but is not. I see a lot of developers kind of making this mistake of treating functions in their code roughly analogous to a tool for a model, which is not the case again. For a model, a tool is basically just a contract. It's not really something that the model will ever execute or knows about. All it needs is a contract that to solve some problem that is given to the model, it has access to this tool and its specification and can do something. That may or may not map to a single function. That may or may not map to a stateful function, stateless function. The model doesn't care. But if you lump it together in your code base without explicitly defining them, you start to create these dependencies which creep up and start to cause problems later on. Third one is model providers. Model APIs should be treated as external replaceable resources. So basically, this is to say that don't confuse the model and its API with the provider and its API. So harsh lesson for people who adopted OpenAI's Assistance API, for example. If you did use it, you were locked into a system which was subpar in a lot of ways and is now obsolete in less than a year of being available. So that's one very difficult lesson, to not confuse the model APIs with the provider APIs. Principle 4 is context. So explicitly defined processes that reduce application and user state into context, which means that unfortunately, or I guess fortunately, now all of this context from one place is useful. If I know who the user is, what their history for interactions, what their history of interactions with my application has been, what they're looking at the screen currently, the more we know about the user in a particular instant, the more useful features you could build now. But now then that kind of creates this problem. And if you've built any large scale prototype or product with language models, you quickly start running into context as a problem. So it's a non-trivial problem that this is the kind of stuff that you do have to solve for when you're building an agent. But one principle to keep in mind is explicitly define processes that have access to state and things that have access to reducing state into context or building the context. And you can kind of architect your system around the fact that they will need access to all of the data flowing through a single point. The rest of the system could be parallelized or thrown into a background queue or whatever you have. So this is 4. I will go to the next 4 in a second, but please feel free to ask questions, pause me. I definitely don't want this to be like a lecture. So the principle here is actually explicitly define processes that reduce application and user state into a context. So what that means is the final context that the model gets is this huge prompt. It could have images in it, it could have instructions, and it could have different data. The problem is if your entire application assumes that you will need access to all of these, now you would want to you can't split it up. So all of the gyan about like microservices architecture, everything goes out the window, because if you don't explicitly define this boundary of this is the part where I contextualize, take some actions, and these other things can be separate. So in the shopping cart analogy, the view is a detail that should not be dependent on the context directly or should try to hoard it. But let me think of a better example. Yes. So for example, if you explicitly define processes, like you could in your code have a particular function that puts the user data and the instructions together into a prompt, right? If the logic for this function is thrown around across the code base, when it comes time to rely on prompt caching in the future, you don't know which part of the context is going to come from which function. So like this is kind of the analogy for context definition would be if your application is stateful, the parts of the stateful bits should be isolated. So that's the same idea here, that instead of like every part of your application kind of dependent on constructing the context, you have one particular service that that service needs to exactly. So yes, so okay, for example, instead of trying to imagine if you have these different reducers that take a user state and then convert it into a prompt. So it could be about the user, their preferences, etc. You could have basically a function that transforms this and saves it as a materialized state in a Postgres table or something. So that's kind of the idea. It gets, I mean, I think when I will get to examples, it would be slightly easier to explain. Okay. Yes. So the next 8 factors. So first of all, and this is very important, most products should start here, but most people don't. You should start with ground truth examples of expected prompt results. It's very, very important because I've seen so many times working with different teams that at some point in the future, they would say, hey, my product works, but every now and then it hallucinates a detail. And if you don't have ground truth examples of what it should do and what it shouldn't do, it's very hard to figure out why it's hallucinating and what's exactly broken. So you would hear something like one of the more common things would be summarizing an article and let's say keeping certain details and attributing it. And sometimes a client's prompts would be returning a detail that is completely hallucinated, was not in the article. And now, they're now racking their brains on why this is happening. When you have ground truth examples at the outset, you know what behavior you want. You can use those ground truth examples to, first of all, do few short prompting. So you can actually tell the model, hey, look, this is an example of the correct behavior. And second, you can also evaluate it and automate that test in the future. Without that, it gets very, very messy. Then we have reasoning. Divide parts of your applications into deliberative and impromptu reasoning. So for example, deep research is a deliberative UX, and the functions and the backend needed to create deep research is very, very different from what you would have for like just chatting with GPT-4, for example. So having those very, very treating them differently, knowing that like impromptu can be treated as more or less stateless, but deliberative reasoning will take time. It will depend on the outcome of the previous search or the previous function call and the one after that and the one after that. So it needs a lot more work in ensuring that that state is managed correctly. And that actually kind of brings me to the next one, which is use workflows to model and run deliberative processes. So I think the deliberative reasoning, the traces, I'll just try to. For deliberative reasoning, you want to still maintain the ground truth for verification. And again, you can use the ground truth. So my recommendation to people basically boils down to don't start by like prompting first, start by defining the desired behavior first. And when you do that, you have access to this small or large set that you can use for few short prompting, that you can use to run like simple evals. And also that forces you to structure what parts of the prompt, to like focus on for certain behaviors. So for example, one common issue I see with developers is not giving negative grounding. So let's say you have a section in your prompt which does rag and dumps some documents. Very common pattern is if there is nothing, it's an empty string. That's really bad, because if you run that same prompt with that same prompt does not have any information about what the system did not find, and hence there's a decently high likelihood of the model coming back and making up the name of a product or making up some detail. And this was a funny kind of an incident just yesterday. I think Cursor's support bot gave an answer somewhere that they're going to restrict it to one computer only. And that was a hallucination. And there was a mass cancellation and like a Twitter hate storm about it. And it was they hallucinate that detail. So that's kind of, that's the idea. I do mean the thinking. No. I mean, so when you're interacting with a model, there's a little bit of a new paradigm shift, which is with the thinking models, it could take arbitrarily long amount of time. So the same request could be a second long or it could be a minute long, and you do not know in advance. So for example, if you have that in the same literally Heroku like worker or pod, if the request exceeds a minute, it's going to fail. So you will have to put it in the background worker or something. Like you have to treat it differently. And the problem is not that from a model's standpoint, it's actually similar, the same behavior, trained to do different things. The challenge is that from the application standpoint, when you're running a impromptu request with the model, there's a very tight expectation of how long this would take and what this would cost me. But deliberative reasoning request, you do not know in advance how long it will take, and you do not know in advance how much it will cost you. So that's that. So it depends on the nature of the problem. For example, if your problem requires out-of-the-box thinking, then adding examples, any example or too many examples can be problematic. The model might overfit and say, start to just follow that same example. But on the other hand, if the problem is helped by specificity, then you do want to add it. So for example, a lot of people would design their chatbot by saying, hey, you have a quirky personality or something like that. And then they would be unhappy with a system, let's say that model responding with too many emojis or too many things. And the natural temptation then becomes to keep adding instructions. Don't use emojis, don't use this, don't use that. I think a better way to just do that is just to show an example chat that, hey, you are a sales assistant at this such and such e-commerce company. You have this personality, and here's how you talk. And that can be more information rich for the model than just tacking on instructions after instruction. Does that make sense? And the last one is save traces of model executions for debugging. So let me define that more clearly. deliberative and impromptu, I'm using this so that because so many providers have different names for the same thing. You have a reasoning model, you have a rumination. This is a whole new thing apparently, but you have thinking models and so on. The point is that we have models today that are very good at solving things. For example, chatting. They're very good at chatting, and those are you get the response immediately and without any unexpected latency. Like you're talking to GPT-4 over voice mode. You know exactly. You have an expectation of how it's gonna behave. With deliberative ones, for example, if you send a request to O1 Pro for some reason, it could come back in 2 seconds. It could come back in 2 minutes or longer. So that's the need for bifurcation, basically. So again, all of these principles, they're for essentially guiding the architecture of your application, your agent, in a way that you don't run into common pitfalls later. So, like for example, you start with, let's say you want to build a bot that helps you fill out a college application, right? And there is a chatting component to it. That's impromptu. You can do that. And then maybe for certain questions, you would like the model to think more before answering. If you dump all of that in the same function and you run it locally, it works. You deploy it to Heroku, for most queries, it might be fine, but every once in a while, it would take too long and the worker would be killed. So then you like separating it into different kind of categories forces you to think about how you're going to run it. So like the longer like chain of thought reasoning style requests, you could run in a background worker, for example. And the more impromptu ones, you can just run ad hoc. Well, I mean, so everything seems impromptu, but when you start an O1 Pro request, it has to switch into a very different mode. Like you could switch away from the tab, come back, it would send you a notification. That's something that is run and tracked separately entirely. And similarly, deep research has, if you've used it, like it's a whole different way of like working with ChatGPT. Yes. So the last principle again seems very trivial, but saving traces is very important because one, these are unpredictable systems. They will do things that are weird every now and then. The only way to know is to actually observe and track it. But also at scale, it becomes really powerful. If you do have high quality traces, you can distill the same kind of behavior into smaller models, much smaller models that have a fraction of the cost because you happen to be tracking them correctly. I mean, this is something that I've kind of shipped a product, it got usage, did not save the traces, and then later on I was like, oh shit, there's no way for me to make use of all of those interactions. So by trace, so let's say you make a request to OpenAI and you save the log of that request. This is a request and this is a response. So that would be a simple log. But often your applications and agents would do something as a series of steps. So single request is not valuable. Like if it's doing step 5 of some task and you're not tracking what was the step 4 before this for that request, it is impossible to say what went wrong. But a trace would be a collection of logs that are related in some kind of logical order. So let's say a deep research progress is a trace. Exactly. So, I mean, for example, let's say you have, again, the college application idea, and in the end, it messed up on one of the essays. In order to find out what went wrong, you need to have the history of all of the actions taken up until that essay, and not just the prompt that was used to generate that particular piece of text. So, because it could be that it was collecting the wrong information. That was the problem. And more often than not, the problem is not with the model. More often than not, the problem is the prompt. Like I've seen, for example, especially with JavaScript, you would have state dot variable misspelled and it's going as undefined to the model. And the person's trying to figure out why it's hallucinating. But it was never actually sending the right prompt. Like it's all too common to not look at what's actually happening. Trace is just a set of logs related in some logical ordering. And because, sorry, please, no, please. Right. So, I mean, there are tools now for facilitating this, and this is not very trivial because not only can you have multiple steps, you can also have branching. You can also have something fail in the middle of an execution or in the middle of a prompt. So it depends, but the idea is essentially just as a principle, whenever you're making requests to a model, make sure that they're easy to log, trace, and collect. And then there are tools. Again, I'll talk about tools in a second, but there are tools like Langsmith, yes, or even something as simple as like your own like OTLP endpoint. Like you don't need something fancy. You need it for that one time when things are going wrong. You need to figure it out, like why something is going wrong, and then you will thank yourself for tracking it. Cool. So factor one, prompt. Treat prompts as first-class citizens. Manage separately from code. I mean, the benefits are obvious, but I think more importantly, the hygiene of maintaining prompting separately and like making sure that you're following best practices. That's something that's not right now actually currently being followed. We don't have tools that we have tools that can automatically lint your code, but we don't have tools that can lint your prompts. And we will see these kind of things in the future. And the best thing you can do is to start treating them as separate first-class citizens. So lending prompts, I mean, you'd be surprised again how many times people would send like malformed copy-pasted data into a prompt, or spelling mistakes, or not following simple things, a simple personality prompting, and so on. So for example, right now, a lot of the prompts, when they're inside the code base, there is no visibility for people outside of the engineering team on what is it really happening. And again, there's no linting, which means that there's nothing you can enforce. In principle, you could actually add a cursor rule that for all .prom.txt files, make sure that there are no like major grammatical errors, like they're written with a certain structure in mind, that they mention the company name, etc., etc. Like, so that would, I foresee a lot of that happening. Similarly, actually, the evolution of this, I would say, is creating playbooks. So not just small prompts, but like prompts that have about like information about the company, the product, the user, all these huge list of rules. Previously, models weren't even following that many instructions, so it was not very valuable. But now I'm seeing people with kilobytes of prompts going in with like different rules for what to say, what not to say, and all this. I'm not a fan of the prompt database analogy, because in my opinion, prompts are not state either. I can get into that, but this, like, what I'm trying to say is that you got to treat them separately. They're definitely not code. That depends on the org and the project. That's a very hard question to say, but if you give me an example, I could tell you that in a lot of product teams, and when you're building features, actually it's actually easier and a lot more powerful for the product team to own the prompts, to be responsible for them, to be the one thinking about them. So I think I'll come back to this a little bit. So right now, almost all of prompting is vibe prompting. Like mostly, even my flow is I would go and try to talk to ChatGPT, see if it can solve the problem, what it's stumbling at, what information it needs. And when I'm happy, I would like turn that into something else in my code base. And to be honest, that's a reasonably good framework to do this. But of course, when you want to ship something in production, then you want to be increasingly more confident of the behavior and that you expected being followed. So again, got to maintain examples. If you have examples, you can always simulate interactions. So you could literally ask a model to pretend that you are a user, like say this, and here's an example of what a user might say. Otherwise, even simulation prompting has it, like then you have to figure out the prompt for the simulation. Exactly. So you could use traces for feedback. Like if you are maintaining prompts separately, the lots of examples separately, you put that together and you can have a system where you can somewhat reliably like reproduce a problem or test in advance or set up an eval and so on. But especially if your prompt is embedded deep inside your code base, that only the prompt is only constructed at runtime, that's very, very hard. I would say like the best, one of the simplest formats that you can have is just use a Ginger template for a prompt. And at runtime, you could trace the variables that went into doing that. So at least you can reconstruct what happened and which parts contributed to the problem possibly. I wouldn't say that the testing is necessarily different for reasoning and these, because for most real world applications, you don't really care about the reasoning trace. You just care about the output. So you can pretend there's no difference between the impromptu output of a prompt or the output of an impromptu prompt and the output of a reasoning prompt. But in some cases, if the reasoning steps do matter, then obviously you will have to separately test that. I mean, if you're talking about testing and so on, I think that's. But, yeah, was that the question? I didn't understand actually. Yeah, right. I think I have not seen that happen too often right now, but I've not seen that happen too often right now. Usually the requests are pretty straightforward when you're building agents. But of course, in some cases, like there are people like there's a lot of inspiration from deep research type interfaces and type workflows to happen. And of course, you need a lot of state management and managing latency and figuring out if you're going to run out of tokens simply because your reasoning trace becomes that long. I'm gonna rush commitments. Makes sense. I'm gonna rush through this and then actually open to questions. Yes, so I'm gonna come back to that, but yeah, no, I understand. So okay, let me just run through these slides. There's nothing too complicated, just simple ideas. So like, don't hard code prompts in code. Don't use LangChain. Do use, there's a little bit of extra effort in doing this in the beginning, but do separately track your prompts. You can use Ginger templates, you can use simple interpolation, whatever works, maybe a prompt database or whatever, but basically don't hard code it. Second is, of course, explicitly isolate tools. Again, coming back, it kind of feels like this is a tool for a language model. In reality, that's not what the tool is. The tool is the doc string. And if you were instead like separately defining a tool interface, forces you to make sure that, because the implementation is not what the model needs. The model needs documentation, the model needs examples, the model needs the definition of the interface, right? And you could actually call whatever function in implementation internally, but tracking that separately. So don't lock yourself into any API like model providers, API or product like Assistance API and so on. And the reason is that the abstractions are still being figured out. We have Responses API today. Something new might come, and maybe a memory as a module is launched doesn't work the same way as Responses API does. That's a trap. That's, at least for the foreseeable future, I would strongly recommend against it. Explicitly define processes that reduce application state. So basically, don't mix reducing information into prompt or building up a prompt and the logic of in the business logic together. So you want to build up a prompt, send it to the model, get it back, and then separately have the business logic either before or after. Keep examples. They serve as benchmarks. They help you actually come up with a good prompt and then test it. And then you can also always use them for evals and so on. Divide processes into deliberative and impromptu reasoning. There are different tasks that might require reasoning. There's some that don't require reasoning at all. Use workflows. And so actually, Julep is a workflow orchestrator. So shameless plug here. Use us because it's a very, very, very good product. But essentially, there are systems that have been designed and tested, battle tested for running systems reliably for days and months, if not more. So your regular Lambda function is not designed for that. So explicitly use these workflows. These are designed to capture state, maintain it. So this is actually what a Julep workflow looks like. So it's literally a valid workflow, and you can have hundreds of thousands of these running in parallel. And the state management is basically the workflow orchestrator's headache. Use traces, some additional insights, baseline first developments, establish a baseline behavior, have some examples, have an eval, then make changes iteratively. Because what happens is it's very, very easy to start adding instructions and start adding complexity. And then the system or the application getting into a regression that is unexpected or that used to be broken before and so on. System 1 versus System 2 intelligence, balance both. So state management, use databases or caches for state. Try to ensure data integrity, consistency. A lot of things, a lot of the tasks that we now solving with AI can actually have very important side effects, like stateful side effects. So if you have something that should draft an email and review it and then send it. If the review step fails or does not behave correctly, you might lose state or end up creating like infinite drafts and so on. So maintaining that, observability and monitoring. Oh, and to remember the 8 factors easily, twerp.com. I couldn't buy it. It was already taken. But traces, workflows, examples, reasoning prompts, context tools, and model providers. Yes, exactly. Like I think the idea is that the interaction that you have with the model is a new type of, computation. Like it takes time and it takes a lot of context to figure out something very valuable. Keep that separate so that you can manage and maintain that. And then you can have these other microservices or functions that you can independently test independently. Like if you mix them together, it basically runs into an impedance mismatch. Impedance mismatch is this idea that, for example, fundamental design of two systems being used together is not matching. For example, SQL queries and code does not mix. And hence, if you are composing SQL queries inside your functions, that can be very dangerous, right? So similarly, like you want to isolate your SQL queries the same way you want to isolate the prompts. That's kind of a little bit of an analogy. So I would say something along the lines of baseline first development. You first of all, if possible, you don't want to like do too many things in one prompt. So there's a friend of mine came up with this law of conservation of intelligence of a prompt or context window. So there's only a limited number of cognitive tasks or limited amount of cognitive load that you can give in context window before it starts to fail in subtle ways. So obviously it's not a real law.
What's the issue? Oh,
No, not the largest not the amount of context, but the amount of cognitive load. So it's very kind of, I mean, it's not precisely definable, but the idea is, imagine if you tell Gemini Pro 2.5 to solve the ArcAGI2 challenge, it would be a single problem, tiny, but it won't be able to solve it because there's a certain amount of cognitive capacity that it has. Similarly, you could start adding instructions, even simple instructions like, stop using the word please and so on and so on. The more you add, you're basically taking away from a finite pool. So kind of always remember that. So try to do as less as possible in every context request. And that's also a really good best practices in general because it saves you costs down the road. It's very messy right now. Reasoning increases the global cognitive capacity, but it does not necessarily like there's still always a finite amount. So it depends. But I think a useful answer to this would be, in the future, I can definitely foresee tools existing for something like this. I mean, other than my friend, and when I heard it, I was like, that makes sense. Other than that, I've not actually seen much research on something like this before. But in principle, you could figure out from perplexity or attention heat maps or something that the model seems like it's running out of, fuel, so to speak. But for now, the best way is basically just this. There's no easier way. Establish baseline, a prompt is working. Now you want to add something to it, and so on. That's the only way. My personal experience with prompt optimizations has been that once you learn how to prompt decently, you're usually way more informed about your domain and your product requirement than a prompt optimizer. So it's a hit or miss. Like if your use case specifically works with a prompt optimizer, then that's amazing. That'll save you a lot of time. But not all use cases work with a prompt optimizer. Like a lot of times I would toss something into a prompt optimizer, it would just make the prompt worse. So this is like I've used Claude's prompt playground. So you can basically tell Claude that this is what I want. This is my current prompt, improve it. Sometimes it works, sometimes it doesn't. Sometimes it doesn't do anything. Sometimes it changes. So it's very hard to predict. And again, without any baselines or evals, you can't really tell if the prompt was optimized at all. Like if you're just vibe prompting, like you try a prompt, you don't get the answer, you throw it into Claude Optimizer, you run it again, it gives the answer this time. That's no guarantee that the prompt has been optimized. That's too small a sample. Also, I think the other thing, the reason I didn't call it eval first development instead of baseline first development, evals are very hard to create. So when you're starting out, like when you're building a product, like, okay, anyone, whoever, and you guys are all built agents. How many of you have run thorough evals on it? So it's hard. It's very hard. Like if there is that much like incentive, then maybe it makes sense. Otherwise, when you're trying to create this, it's just silly to go and first establish an eval. An easier thing to do is make sure to document in my head, this prompt should do this. This is an input. This is an output. It's a solid example for me. If nothing else, 20 iterations down, I can just test this example. Does this still work or not? Right. And this little bit of discipline at the beginning that, okay, I'm just going to sit and just write down the example helps, because post facto, like once you have a long ass prompt, creating examples is also very hard. So not necessarily. I mean, so, okay, so if you think about it this way, in fact, I would argue that that's a poor application of agents in a lot of ways. So when you ask an agent to, let's say, go and open or check your email account, it will use some tool, and that tool already makes up some API calls, etc., etc. It's deterministic. It would be wasteful to have the model figure out the tool from scratch every time, like write the API and then make a call. You could do that. You could do that, but it would be wasteful. And now you are introducing a possible point of failure, because these systems are stochastic, like they will have some error rate always. So see, it depends on how you're thinking about agents. So one way is there are no integrations or there's no deterministic code or logic that I have access to, and I want to solve this problem. Then actually an open-ended agent is perfect for that job. You can just say, hey, look, I don't know that there could be an API call, documentation, go figure it out. And it will go do that. And that's very valuable. That's very powerful. But it depends. And also often you might actually want to turn that back into a workflow so that you lose the, stochasticity of it. So in Julep, so this prompt, for example, could have reasoning mode turned to on. The Julep is just the orchestrator. It's the system that basically, this is kind of a distillation of all of these factors. Like you have a prompt that's separate, you have state that's separate, you have a workflow runner that keeps track of the state. All you have to do is connect to it and give it, input here being topic and so on. And you could use the reasoning trace yourself. We're agnostic to that. So as the output of this step, you will have the reasoning trace. Maybe you could build a workflow that uses it. So this is kind of a tool for you to build an agent and do what you want it to do, and you could use the reasoning trace or not. So see, tool calling is it's just a fancy term for a specialized kind of prompting. Like you could build your own tool calling without using the official one. You can just say, hey, here's a list of the tools or methods or whatever you want to call it. You can, in your answer to this prompt, if you want me to run this thing for you, you can say call and then in brackets this thing, and I will run that for you. That's all that's happening. So now your job is to make it easy for the model to understand this tool, when to use it, when not to use it. So what I've found is parameterization hurts. So if you create a tool and add tons of parameters, things that can be tweaked around, you're kind of really increasing the permutations of what might be acceptable behavior. Also remember that you're sampling from a like probability landscape in a way that is non-deterministic. So, and unfortunately, when the model is outputting tokens by token, if it chooses, and then like, let's say the first parameter value that it chooses, if it chooses one that is slightly less likely, it might get stuck into making the next choice that is worse and then worse and then worse. So rather than giving it too many parameters, if possible, you want to like break it up into multiple tools and like multiple steps. So that's one, like the smaller as self-contained as possible the tool is, the better. If the tool is something that is not a common pattern, then you have to give it examples, because your model can't read your mind. Like you understand what this tool does, but if it's not a common pattern, let's say, I don't know, something very specific to your location or your office environment or something, like you want it to, let's say, activate an Arduino servo to do something. It doesn't know what intended or unintended consequences that thing might have. So you need to really explicitly like lay that down. So lots of documentation. You can think of models as like a shitty intern with a lot of potential. So if you give it lots and lots of instructions and information, that is like that's good for it. But if you're like, go do this thing for me, that can be. And this is actually, this came up earlier. Even with the most intelligent models, you want to stick to this because this is more reliable way of building this. And that problem of like running out of the cognitive capacity, someone should write a paper on this, but like that happens suddenly, and that happens completely in a way that's completely opaque to you. So you are happily building your application and you're adding an instruction, like you say, hey, here's this piece of information. Oh wait, let me also tell it the user's age. Oh wait, let me also give it the current time. Let me also give it this. At some point, one of those things will start to mess with it, and it's impossible to know like when that will happen.